Hey guys, glad you're back. Checking out this next activity. So we're going to continue on with these tasks. Remember, these are developed. These videos are developed since if you're not here at school, you can't build the kits. I built them for you. You get to test them and make sure that they work, and then you can document what you need to in your notebook, as I state on your engineering design essential skills sheet, and then take the quiz. And this stuff will help you get the quiz completed and be successful because you'll see how it works. All right, so again, let's see if I can get this right. Here is all our stuff that we're going to be doing with LJ Create and Google Classroom and all that. And then here is our code and our programming that we're going to use. So we're going to hop in, and this is for day 12. We're going to be doing opening models and prototypes task. You will improve your motor of the turntable. I'm going to show you how I made it. And then we are going to develop this to be able to turn exactly one revolution. And instead of stopping somewhere in this area because the motor moves a little bit, we're going to use a magnetic sensor that puts it right where it needs to be. And it's going to go counterclockwise, and it's going to stop in the same position every time. You're going to have to then in your notebook give a list of where you put your motor, your switches, and any sensors used on your documentation. And then you'll have a quiz to take. So those would be the things that you're going to complete today. So let's go ahead and open up Models and Prototypes task. Models and Prototypes task. Here it is with the hand. And let's get started by listening to the directions while I set things up.
Lab work. Models and prototypes. Models and prototypes can be used to test designs and find any problems before building a final design. Models and prototypes can be repeatedly tested and improved. Improve your design of the motor of a turntable by using a magnetic sensor to make sure the turntable stops in the correct position. Use the help sheets for assistance.
Okay, so obviously we're going to improve on this. Now, this is a picture of the original turntable, and this other one we're going to be using is going to be enhanced with a magnetic sensor. Kind of looks like just an extra shaft with a cord on it and then hooks up. Well, that's a sensor. So here's the brief. In the previous lesson that we built a turntable, we rotated one revolution and it stopped. And it was all based on just trying to find the right timing and to find the right speed. Well, you might have noticed that the turntable didn't always stop correctly, or it was somewhat close. Here we want to modify the turntable so that when we press the switch this time, click, it will go exactly where we need it to go. So let's get started with developing that. So we're going to modify the design that we originally had. I'll show you how I modified it. We're going to use the programming software. We're going to connect a motor, magnetic sensor, and a switch to the correct spots. We're going to use the controller to test its function, download the program to the controller, test the model, decide on a suitable method of testing, and then we're going to see if it worked. We're going to evaluate it all. So this was the original design for the model. Now I'm going to show you under support materials. I went here and used building a turntable. Following these steps, I built something very similar to this. Okay. Initially, I built the same exact thing, and then I had to modify some stuff because our design brief didn't say anything about having a light. It said to have a switch, so I had to change out a switch. Every single one of these points here had a magnet that was going to be read by the magnetic sensor. Well, if I have that, it's not going to rotate exactly one time if it's stopping every time it's on one of those spots. So there's some things I had to change, and then the code over here will show that. So I did go through it. It did take about, I don't know, 20 minutes to make, 25 minutes. So that saves some time here. So let's go back here and let's take a look at what we have. So if we look down here on the camera, I have the brick and I have everything kind of set up already. So this is, you can see how I set it up. This here is a magnet. Originally there was magnets in every single one of these spots, but I just want the one there so that it's going to stop it right over the sensor down here. That's there. There's another magnet you can't see back here just as a I guess, a checking station. And then here's my switch. Okay, so let's go ahead and see the code that was put together. Again, took the codes, put them into a Google folder so we can download it. This one I called turntable, or improved turntable. Improved turntable. So I'm going to go over here again on the desktops, not on the Chromebooks because it's just not working right. And we're going to go to improved turntable. And we're going to open that. Let me make this smaller so we can kind of walk through what we're looking at here. So again, we start out with an infinite loop so that this thing can run constantly until we say we're done. So the infinite loop starts with having the switch. Now the switch, the button switch here, this is in input output 0 right here. And what happens is if the switch is on, so yes, it's on, that would mean the button is pushed down. Okay, the DC motor, which is in DC 0, the motor is going to again spin at 75, so a little faster than I had it last time. We have the magnetic sensor, which is over here in input output 1. If the magnet is off, with the 0, then the motor is going to continue to run until it gets to magnet 1. Otherwise, the magnet will stop. It will stop at that magnet if it's on. Okay, so that's how it's going to work. So this is how the code is written. It's in a loop so it can work continuously. So what I need to do is take my USB cord, plug it into the brick, make sure it's all hooked up, which it is. Go ahead and download. Make sure I have this open so you can see. Okay, now that it's downloaded, unplug. I'm going to go ahead in here and open up the folder. And again, I'm just created as program A, just wrote over the other program. And again, now when the button is on, it's going to rotate. So right now it's not on. So because it's not on, it goes right down here to motors off. But once I turn it on, we're then going to see it move counterclockwise till it comes to this magnet and stops. So there it goes. You see the magnet's turning at a speed of 75, and it's going to stop exactly where it needs to be. Okay, so that worked exactly where it needs to. There's no give left or right. It's right where it needs to be. Now, if it does get off a little bit and we push the button, then the motor is going to run it again until it gets exactly where it needs to go. And it will stop at the same spot every single time. Now, what if it got moved a little bit here again and I push the button? We've already seen what happens. It's going to make its way back to the sensor. Now, just to kind of play with it a little bit, I'm going to go into the kit and I'm going to show you some things that were set up before when I just used the supporting materials list. There were other magnets that we had in here. So there was actually a magnet here, and I'd have a magnet here and here. But just for now, I'm just going to show you this. Now, because there's a magnet here and the sensor, the magnet is reading it. So if the magnet is off, it spins. But once the magnet touches something, if it's yes, if it's on, then it stops. Watch what happens. Obviously, it's off a little bit here. So when I hit the button, it's not going to go all the way around. It's going to stop here. We'll show you. So it spins, and then it stops there. And why does it stop? Because there's a sensor. There's a magnetic sensor that's catching it. So if I had a magnetic sensor on every single one of these, and it gets off just a little bit, it's going to spin till it gets another one of those magnets. So now it's halfway. So let's say I added in another magnet here. Nothing different really going to happen, but if I push the button, it's going to spin till it gets to this magnet. And then if it's off a little bit and I hit the button, it's going to spin until it gets to this magnet. So now the sensor is doing its job and it's recognizing it needs to stop right here because the magnets are connecting between the sensor and the actual magnet there. So adding the other magnets just makes it have different points where it's going to stop. It's doing exactly what the program wants it to, and it's going correctly in the way that the flow chart is written. So that's what we want. Okay, so if we go back here to the directions that I wrote, what do you need to put in your notebook? You need to give a list of where you have the motors, the switches, and the sensors listed. That's all I'm looking for you to include in the notebook. So write down what's in input output 0, what's in input output 1 based on what I spoke about before, and what's here in DC 0. I hope you can figure that one out. You don't have to do a sketch of the turntable. You can if you want, but that is just an optional piece. All I need is a list of where you have all your stuff located, and then you can take the quiz. So that's it for this activity. I'll see you back next time when we do another activity. We're actually going to take and make a stoplight. That's going to be the next activity we're going to do through these videos.